kind of the main idea. In the next lesson, we're going to be learning more about what it means to be finding the composition of functions. But let's just review some things. Notice how in black here I have a couple of equations, like f of x equals 1/2 x plus 8, and here I have g of x equals 3x minus 4. If we recall from chapter 1, we learned about function notation, and we use these special symbols f of x and g of x to identify functions, and we can name a function with any letter. So it just so happened that we named this first function function f, and the second one function g. And in the first chapter, I think it was the third or fourth lesson, is when we saw problems like this, and we had situations where then they asked us to find f of 6. And remember what that meant is that we would take 6 and put it in the function for x. So for this one we would use function f. So I would put f of 6, or put 6 into function f. And when I do that, this, remember, tells me the rule of what to do with the value of x. So I'm going to take 1/2 of whatever x is and add 8. So I'm going to take 1/2 of 6 and add 8. Well, half of 6 is 3, and 3 plus 8 gives me 11. So in other words, f of 6 would equal 11. Now that's nothing new. That's what we did back in chapter 1. What we're doing today is what's called a composition of functions. A composition just means that we're going to merge two functions together to get one solution. In other words, here I have, let's look at this example. These are two different ways of writing the same thing. So you could write f following g of 4, meaning we have f and then g and then 4 is the way we'd write that. But the way that we actually solve it is we solve it from the inside out. Meaning I'm going to put 4 inside of function g, and then I'm going to take that answer and put it inside of function f. That's our ultimate goal. Now, if you might see this symbol here we're going to learn more about in the next lesson. But that symbol represents the word following. It means the same thing as what we just did here. So whenever you see that symbol, if you'd rather put parentheses around that g, so that way we can remember that we're going to put 4 inside of function g and take that answer inside of function f, you can do that. Well, today we're going to focus mostly on seeing problems like this. Some of the problems in your assignment will use that symbol following, and we'll look at those here in a minute. But first, again, the way that you're going to do this is from the inside out. So I'm going to take 4 and put that inside of function g. So g tells us over here to take 3 times whatever x is and subtract 4. So x in this case is 4. So I'm going to take 3 times 4 and subtract 4. Well, 3 times 4 is 12, and 12 minus 4 would give me 8. So here's what I just found. I found when I put 4 inside of function g, I get 8 as my answer. Now, I'm not going to put 4 inside of function f. I'm going to take my answer when I put 4 in function g, that answer of 8, I'm going to put that value into function f. So to find my final answer, I'm going to put 8 inside of function f, so it's going to be half of 8, and then add 8. So we're taking 1/2 whatever x is, and then add 8 to it. So in this case, half of 8 is 4, plus 8 gives me 12. So my final answer is 12. So I don't have two answers. Don't think that I have 8 and 12 are my two answers. I'm only going to have one final answer, and that's going to be 12. So in other words, when I put 4 inside of function g and take that answer and put it inside of function f, I get 12 as my final answer. 8 is just a stepping stone to get to that final answer. Let's look at another one. Now you might notice and might think that this is the same problem that we just solved, but the order is different. Here we're putting 4 inside of function f first, and then we're going to take that answer and put it inside of function g last. So let's do that. So it's going to be 4 inside of function f. So it'll be function f tells us take half of whatever x is, so we're going to take half of 4 and add 8. Well, half of 4 is 2, and 2 plus 8 is 10. So I found this to be 10, so now I'm going to put 10 inside of function g. So it's going to be g of 10. So g tells us to take 3 times whatever x is, so 3 times 10 minus 4. Well, 3 times 10 is 30. 30 minus 4 is 26. So your answer here would be 26. Again, that's your final answer. Let's look at another one. here we have, again, two different functions. This time function f is 7x plus 1, and function g is 2x minus 12. Now some people get confused, and they say, well, wait a minute. How can function f change? A minute ago you were saying that f was 1/2 x plus 8, and now you're saying that f of x is 7x plus 1. Why do we have the same letter for two different equations? Remember, what we're doing is we're naming an equation. We're naming this one f, and we're naming this one g. Just like you could name kids different names. You could have in the same classroom two kids with the name Sam. They have the same name, but obviously they're two completely different people. Just like here, we could have two equations named f, but they're two completely different equations. So don't get too hung up on that. So again, what we're going to do is we're going to put 3 inside of function g, and take that answer and put it inside of function f. So when I do that, it's going to be, again, put 3 inside of function g. G tells us to take 2 times whatever x is, so this time 2 times 3 minus 12. Well, 2 times 3 is 6, and 6 minus 12 is negative 6. Now I'm going to take that answer, so again, this is negative 6. I'm going to take that answer and put it inside of f. So f of negative 6 equals, so again, we're going to take 7 times whatever x is and add 1. So 7 times negative 6 and add 1. 7 times negative 6 is negative 42. Negative 42 plus 1 is negative 41. So there's your final answer. So why don't you guys, now that we've tried a few of these together, why don't you try this next one on your own? G following f of 3. So you're going to put 3 inside of function f, and then take that answer and put it inside of function g. So go ahead, pause the video, and hit play when you're ready to check your answer. Okay, so let's see what you did here. So we should have put 3 inside of function f. So this time it's going to be 7 times 3 plus 1, which gives you 22. Now you're going to take that answer and put it inside of function g. So it's going to be 2 times 22 minus 12, which gives you 32. So the idea here is for you to see that even though we're using the same functions and we're using the same number of 3 for both of these examples, we got 2 completely different answers, because you're changing the order of which you're putting in the numbers in. So you're putting 3 inside of function g in the red here, doing that first, taking that answer and put it inside of function f, or for this one you're putting 3 inside of function f first and taking that answer and put it inside of function g. Now you might still be struggling, so maybe having a visual aid here so you can see what's happening might help. So this is using a function machine. It's the same exact process. So here, whoops, we're going to solve this problem. So this tells me I'm going to take 4 and put it inside of function g. We're using the same 2 functions that we just looked at previously. And then we're going to take that answer and put it inside of function f. Now, because some people struggle with this and they think, well, I'm going to put 4 inside of function g and then put 4 inside of function f and get 2 answers. That's not what we're doing. We're putting what we have as our first function. We're putting 4 inside of that first function. Now, this first function tells us to take 2 times whatever our input value is and subtract 12. So 2 times 4 is 8. 8 minus 12 gives us negative 4. Now, I'm done with the 4. I put it 4 in the first equation. I'm done with it. Now I have negative 4 that we got spit out here. Then now that's going to get put into this other equation, this other function. So negative 4, when that gets put inside of here, so I'm going to take 7 times negative 4 plus 1. Well, 7 times negative 4 is negative 28. Negative 28 plus 1 gives me negative 27. So my answer here would be negative 27. I don't have 2 answers. It's not negative 4 and negative 27. It's just the one, negative 27. So hopefully this gives you a better perspective of what you're going to be doing in your assignment. Speaking of assignments, let's look at example 3 in your assignment. Example 3, let's see if I can erase this. Whoops. Example 3 looks like this, where we have a square in here. So we have negative 3 times x squared plus 6. It's very important that when we square something to remember if it's negative, especially to put it in parentheses. So what we're going to do here is we're going to put negative 2 inside of function g first. And then we're going to take that answer and put it inside of function h. So negative 2, when I put it inside of function g, that's going to be negative 3 times negative 2 being squared plus 6. So it's important when you put this in your calculator to put the negative inside of parentheses. Or we could do it without a calculator and say negative 2 when you square it is a positive 4 times negative 3 is negative 12. And negative 12 plus 6 is negative 6. Again, that's not your final answer. That's just our first part. Now I'm going to put negative 6 inside of function h. So now when you do that, it's going to be negative 3 times negative 6 squared plus 6, and I'll leave you to figure out what the answer is going to be. But one of the other reasons I want to look at number 3 is in your assignment, we see this symbol again. We're going to see a lot more of that in the next video when we talk more about it. But again, when you see that, for right now, you can just think of that as being the same process of what we're currently doing. So you can replace that with parentheses. So now we would put negative 2 inside of function h, and take that and put it inside of function g. So the process is exactly the same. It's just that we're using a different symbol. And we're going to talk more about that symbol in the next video. So with that, hopefully you understand how to find the composition of functions here. And good luck on your assignment.